Transmission start. Welcome to Where Did the Road Go? Join us as we wander off the path and explore lost history, consciousness, the paranormal, unexplained mysteries, alternative thought, and much more. We are present on the web at wheredidtheroadgo.com. Now here is your host, Soraya.
Welcome to this memorial edition of Where Did the Road Go? I just found out today that Wal Thornhill passed away. He passed away on the 7th of February, 2023. Wallace Thornhill, he liked to be called Wal. His obituary says, passed away peacefully in Canberra, surrounded by family. Much loved and devoted husband of 57 years of Faye, loving father of Nikki, Tanya, and Bronwyn. I think it's Bronwyn. And their partners, Gal and Brian. Physicist, cosmologist, natural philosopher, independent thinker. Wal was a world-leading theorist of the electric universe cosmology, the chief science advisor to the Thunderbolts Project, and a science consultant for the Sapphire Project. I got to talk to Wallace twice. I had Wal on in 2014 and 2015. He was one of the people that when I started doing this show, I definitely, absolutely wanted to talk to, and I'm glad I got to do that. He was only 81 when he passed away, which, I mean, he achieved a lot in his life. So there's that. But I was kind of shocked when I got the email from Thunderbolts saying he had passed away. They didn't announce it till the 12th, which is today. So I had planned on remastering and re-releasing his shows as it was, and now I figured now's the time to do that. So thunderbolts.info is the Thunderbolts site with tons of stuff from Wallace on it. You can go check that out. And this is the two interviews I did with him early on in the history of the show. For some reason, the sound quality on the second one is worse than the sound quality on the first one. I don't know why, because it was 2015, and that was a long time ago. But clearly, my equipment did not improve between the two. Anyway, it's a very interesting conversation, and I am honored to have had him on the show and gotten to talk to him about this stuff, which really had a major impact on my life when I discovered the electric universe stuff. So here you go, the two shows I did with Wal Thornhill. And it's my honor tonight to have with us Wallace Thornhill. And you're coming at us live from Australia, aren't you?
That's right.
And you are, well, honestly, your work completely changed the way I look at the universe. Your work with the electric universe, it was just, as soon as I came across it, it was just so astounding and so mind-boggling. And partially in its simplicity, it was just so obvious once you know what to look for.
That's the basis on which I work.
Do you want to tell people a little bit about where the initial theory of the electric universe came from?
Well, there have been headlines in the paper back some decades ago when Hans Alfvén was working on plasma cosmology, and it was then called the electric universe. And also another pioneer in plasma science, and I'll talk about that in a minute, Winston Bostick also was producing galaxies in his electric discharge experiments. So it does have a long history. Also, going back more than a century, in Norway, Christian Birkeland was reproducing the aurora and rings and sunspot activity on globes, magnetized globes inside a discharge chamber. So the ideas behind it have been around for a long while, but for me it was a process of discovery, working from an initial idea that was presented to me before I got to university, which suggested that the solar system that we see today is not the one that our ancient forebears and our prehistoric ancestors witnessed. And that for me was a huge challenge because, of course, the immediate answer to that was that it disobeys Newton's law of gravity and Newton's dynamics. And so this was a huge hurdle to face. But out of it all came a synthesis, which has finally produced what you might call a big picture, a new cosmology, has only been in place for the last decade or so.
All right, and what role did Velikovsky have in all of this?
Well, Velikovsky was the one who provided this impossible idea that Venus was a comet in the memory of mankind. And I read that while I was at high school, and I was the only science undergraduate who spent a lot of time in the sociology shelves at the library reading myths and legends of various ancient races right around the world. And in doing so, I found that he had made a case to answer. I mean, you can argue with the details of what he said and also bring it down into historical times, which I think created a huge hurdle for him, which may have been unnecessary. But the basic thesis, I found he had provided solid evidence for it, and it was probably the most critical thing that had to be answered. If Venus was a comet within the memory of man, how did it achieve the most circular orbit of any planet in the solar system in a matter of a few thousand years? This meant that Newton's law of gravity is not the only thing that's acting, and this was the challenge that Velikovsky threw down to astronomers, and they just ignored it on the basis that it disobeyed Newton's laws. But he was saying, no, you have to look at Newton's laws, because the ancients also said there were colossal thunderbolts exchanged between planets when they come close to one another, and this obviously plays a part in the mechanism. But that was too much back in the 1950s, and it's still too much, I think, because you won't find any mention of electricity in any textbook on astrophysics or astronomy.
Which just seems absolutely bizarre to me. You would think even if they didn't believe in the electric universe theory, they would still include that to some level in astrophysics and such.
Yes, we have on record one classic comment by a leader in astrophysics who said, we know there's electricity out there, but it doesn't do anything. And yet here we're talking about a force which is 10 to the 39th power times stronger than gravity. So even a tiny amount of electricity acting in space will swamp any gravitational effects.
Now, obviously there are mathematical formulas for gravity and stuff, but scientists don't technically know what gravity is, do they?
That's true. Newton had the sense to say that he didn't know how gravity worked, just that his equation worked. And to think that Einstein answered the question is a mistake, because all he did was to use a form of hyperdimensional geometry to try and explain, to try and actually describe, not explain, what the effects of gravity are. But when you look at Newton's law, the thing that stands out when you look at it closely is that there is no mention of time. Time doesn't play any part, which means that gravity operates instantly. And this is something which, of course, in modern physics is totally anathema. It's not allowed, because Einstein said information cannot be transmitted faster than the speed of light. Well, the sun knows where the Earth is right now, and the Earth knows where the sun is right now. And it's very simple to show that that's the case, because if it weren't so, you would have an effect. The force between the sun and the Earth would not be pointing directly at the sun. It would be slightly offset. And it would have the same effect as you swinging a weight around your head on the end of a piece of string. If it weren't for the string, the object would fly off. Well, there's nothing holding the Earth to the sun except for the force of gravity. And if this force was acting not directly towards where the sun is right now, but where it appears in the sky, there would be a force which would sling all of the planets out of the solar system in a very short space of time, measured in maybe tens of thousands of years, not in millions or billions of years, which is supposed to be the age of the solar system. Of course, what Velikovsky's breakthrough meant is that the entire history of the solar system, the Earth and the human race, is not what we think it is. What we're being taught is a kind of a fairy tale, a myth.
All right. What would you say the biggest problems with the standard model in science is?
Well, there are many. The biggest problem when you talk about the stars and the planets and so on is that the present cosmology relies on the quantum theory at the subatomic level and on Einstein's general theory of relativity and gravity at the largest level. Now, gravity is supposed to control the orbiting of stars and galaxies, the planets around the stars, and so on. But at the quantum level, you're talking about activity that goes on inside the atom and which no one understands. I mean, the top scientists, quantum physicists, say nobody really understands the basis of quantum theory because you have spooky effects. So you've got these two incompatible theories. The two don't work together. So the answer, I mean, the physicists have been looking for quantum gravity now to try and draw the two together. But all of this is just a form of mathematical gamesmanship. The electric universe actually follows the lead of the 18th and 19th century scientists who were trying to simplify things. But today we have a Nobel Prize which encourages people to invent new forces, new particles, so you have dark matter and dark energy and all sorts of nonsense, which is a purely mathematical endeavor and has no real explanation in terms of the physics or classical physics. And that is the big problem which the electric universe addresses.
And I had read somewhere that there are 7 unproven theories that need to be in place in order for the Big Bang theory to actually work. Is that accurate?
Well, I would say that the Big Bang theory is not even a theory. It's just a story. It's a version of the creation myth that the Christian religions and so on are based on. You know, in the beginning there was a miracle. There was let there be light, and everything was sort of created out of nothing. It's the same with the Big Bang. No physicist knows what matter is or how you create it. So to say that the Big Bang created all of the matter out of energy is pure nonsense, because nobody knows how you do that. It's a miracle, and it's no less a miracle than the biblical one.
Okay. What does the electric universe say about the beginning of our existence, of our universe?
Well, the fact is that the astronomer Halton Arp, who died last December, unfortunately, has been named by some top astronomers like Sir Fred Hoyle and the Burbages, Geoffrey and Margaret, and others as the modern Galileo, because his work on peculiar galaxies and an atlas of peculiar galaxies showed him that quasars, which are these objects which are supposed to be highly redshifted and at the ends of the universe, were actually nearby and were being ejected from the centers of active galaxies. Now, the reason I'm telling you this is because the whole idea of the Big Bang sprang from the idea that redshift indicated the speed with which something is moving away from us. But Halton Arp was able to show that the redshift, most of it, was due to the youthfulness of a body. So all of these things which are supposed to be at the ends of the universe are actually nearby and part of a family structure of galaxies giving birth to companion galaxies and so on, which is a completely different picture. There is no expansion of the universe that he could discern. But his work was ignored, and then when somebody tried to discredit it, they used statistical techniques, which was typically designed to fail. So his work has not been seriously addressed. But that paints a completely different picture of cosmology and the origin of the universe, the origin of the matter in galaxies and so on. And the electric universe fits with it perfectly. So I would suggest that the first step for cosmologists is to look at what Edwin Hubble actually said. He felt that the expansion of the universe was the least likely option for his discovery. But nobody teaches you that anymore.
And so the electric universe doesn't postulate a beginning necessarily.
No, all we say is that we're ignorant of how matter is formed. We're ignorant of the extent of the universe, its age, and its origin. And I think this is a perfectly reasonable place to be in the 21st century. Why should we think that in the last few microseconds of our existence on this planet that we've suddenly got all the answers? It really is an incredible arrogance on our part to even suggest such a thing.
Now, just recently you posted a video about the and I forgot what it is, the background, the proof of the Big Bang that they came up with.
Oh yes, the cosmic microwave background.
Yes.
Well, that of course was based on a pure assumption, and the initial estimates of the the temperature of this radiation by those who subscribed to the Big Bang theory was way out. It was actually there were much closer estimates by those people just using a classical approach. The starlight, the amount of starlight around, you would expect that kind of level of radiation at that temperature. But the Electric Universe points out that the signals that have been received recently, which show a polarization of the magnetic field, which follows a rotary pattern. It's quite a large pattern, and it is not explained except by the Big Bangers as some kind of effect caused by this incredible expansion phase right at the earliest 10 to the minus 36 or 10 to the minus 37 of a second. I mean, just even to suggest such a thing shows the incredible hubris of these people. Anyway, the Electric Universe has said for a long time that this radiation they're detecting is not from the edges of the universe, otherwise it would throw shadows. Objects nearby would throw shadows, and they don't see such shadows. But the other aspect is that the electric power that flows through galaxies takes the form of Birkeland currents, which have a rotary magnetic field, polarized magnetic field, and this seems to be exactly what these people have discovered. But of course, when all you have is a Big Bang as your as your model, everything has to be fitted to that, and of course, this is what happens.
Now, what about the Higgs boson? That was supposedly the thing that was going to prove how gravity works.
Well, it was supposed to show, or as an explanation for why matter has mass.
Right.
Well, that was one of the silliest ideas ever, and we've spent more than $13 billion chasing that rabbit down that hole. The reason is that if anyone cared to look at the equation that most people, or the equation most known by everyone, E equals mc squared, it's telling us simply that energy, mass, and the speed of light are all properties of matter. And therefore, mass is an intrinsic property of matter. It doesn't have to be imposed by some imaginary particle external to normal matter. I mean, it really is an incredible thing to suggest that matter doesn't have energy, because we know that when you split the atom, there's plenty of energy.
Well, what do you think they found when they found the Higgs boson?
When you smash particles together with sufficient energy, you get short-lived resonant states of matter, which show up as this incredible zoo of short-lived particles. They have no real significance, except that you may be able to determine something about the substructure of particles. But since people are not looking in the right way at the debris and so on, they're not going to find the answer. You have to have the right model when you design an experiment, otherwise your interpretations go astray. And this is one of the big problems in physics at present. There's a lot of wonderful work being done by scientists, a lot of great experimental work and observational work, but it's all being destroyed by the theorists who are just playing mathematical games.
Now, when it comes to black holes, dark energy, dark matter, I noticed from reading Thunderbolt's articles. One of your sites is thunderbolts.info.
Yes.
And that's where I first really started to learn about this stuff. And from reading the articles on there, when they had announced they found the biggest black hole ever discovered or whatever, my brain immediately was able to read the article and take it apart and realize that what they were trying to say and what they were actually discovering were two different things.
Yes.
And it was amazing to me that that's so easy for them to just put that information out there and make these giant assumptions and these giant leaps when all they were really finding were a couple of gamma rays and X-rays, I think, is the only thing they had actually discovered.
That's right. Yes, the problem that modern cosmology faces is that they see very concentrated outbursts of energetic radiation. And when all you have is the weakest force in the universe, gravity, to drive these outbursts, then you have to postulate incredible concentrations of matter, despite the fact there's no indication that you can actually compress matter to the extent that they require, and also that it uses a physics which treats matter in a way which is non-physical. In fact, we have one of our members of our Thunderbolts team, Stephen Crothers, has shown that the mathematics behind black holes is flawed in about 3 or 4 different ways. And he has challenged the leading lights in theory, in black hole theory, to point out where he's wrong. And the arguments are so simple that you can actually state them in plain English and people can follow it. So I recommend having a look at Steve Crothers' work. He has suffered at the hands of academia as a result of doing this, so now he's sort of independent. He attended a lecture in Europe on black holes where he was invited to speak, but when he spoke and pointed out all of the faults, he said no one would talk to him. And the funny thing is that all of the papers that followed continued the mistakes and ignored what he'd said as if he'd never spoken. And unfortunately, this is typical. When you challenge a cherished belief, and they are beliefs, they're not real science, you get the same kind of treatment as anyone who challenges somebody's beliefs. But black hole theory is nonsense from beginning to end. Where you have a concentration of mass, you have a concentration of energy. And the easiest way to get a concentration of energy has been shown by plasma scientists in the laboratory in what's known as a plasma focus, a dense plasma focus. And here you can concentrate all of the energy from a huge room full of capacitors, into something which is a millimeter or so across, a tiny little donut. Now, this is what we have at the centers of galaxies, only it's not a few millimeters across. It might be the size of the solar system. But it's a concentration of relativistic particles, which obviously have tremendous mass in a small volume, but it's nothing like a black hole. And also, it has the tendency to become unstable and emit jets along the axis of the donut. So, and this is exactly what we see, of course. So the plasma cosmologists have a model which can explain what we see in deep space without recourse to all of these crazy and mathematically incorrect theories about concentrations of mass like neutron stars and black holes.
And one of the things about the electric universe theory is that you can replicate this stuff in a lab.
That's right.
So you can go on.
Yeah, one of the problems, of course, that astronomers have always complained about is that they can't replicate their gravitational models in the lab because gravity is so weak. However, plasma cosmologists have been able to perform experiments using the highest energy electric discharge equipment in the world, like at the Sandia laboratories, the Z-pinch machine. And you stand back a kilometre or two with X-ray telescopes to watch the experiment, and then it costs you about $100,000 to repair the damage afterwards. The energy is so concentrated and so powerful. These are the kinds of things that we're looking at in deep space when we look at these concentrated bursts of X-rays and gamma rays.
Okay. When it comes to quasars, as you mentioned earlier, what do they have to do with galaxy formation?
Well, the so-called black hole, the little donut at the center of a galaxy, which occasionally becomes unstable and emits particles in beams, actually produces matter at close to the speed of light. And over time, Helton Arp found that it formed knots of matter, which then gradually gained in mass over time and slowed down, and their redshift decreased with time in steps, in quantum steps. And this gives you a clue that quantum phenomena are basically an electrical resonance phenomenon, which can actually operate on galactic scales. So there is no dichotomy between the galactic scale and the subatomic in the electric universe. All of this stuff comes together and becomes simple to understand. The quasars go on then to become themselves. They slow down and go into orbit about the main galaxy and become companion galaxies, or they become Seyfert galaxies and so on, which themselves give birth to other quasars. And so you have families, and you can actually determine the genealogy of galactic families. It paints an entirely different picture. It's almost a biological picture of our position in the scheme of things.
When Einstein died, he had just, if I remember right, just given Velikovsky approval to do more research on the electrical properties of planets, and of course that went away with Einstein's death. What do you think would have happened had Einstein backed Velikovsky, if he hadn't died?
Well, that's a good question. Yes, I've been told that story is true, that Einstein was backing the test of radio noises from Jupiter because that was unexpected, and yet that was found to be the case, that Jupiter's the noisiest radio object in the sky apart from the sun. This was unexpected because this was supposed to be just a gas giant floating around in space, minding its own business and not transmitting in the radio wavelengths. So if that experiment had gone ahead, I'm not sure that would have been accepted, because it seems that when you make a really big challenge to science, the problem is that no evidence is sufficient to sway those who stand to lose credibility and even their status in the hierarchy by accepting this data. This has happened time and time again. I've seen it. There is no investigative journalism in science, so scientists are more or less a law unto themselves. They're unaccountable. As much as any church. In fact, Halton Arp said that there are many similarities between the medieval church and modern institutionalized science. And this is a very sad state of affairs. Institutionalized science is designed to fail because real breakthroughs always come from individuals, and individuals are crushed in the present scientific, or the individuals who are making really big challenges get no hearing.
Okay. Now, someone might say, well, the Standard Model is so confirmed by modern science, but that's not necessarily the case, is it? They
No.
often make predictions and then have to change or add more mathematics and stuff to make those predictions work.
Yeah. The models are infinitely adjustable. You've got so many knobs to twiddle, you can match anything. I remember there was a cartoon once where it was suggested that if you twiddled a knob, changed one variable, then you could produce a koala bear. And it is almost like that now. And I think the fundamental problem is that we don't learn from history. In fact, I think the way science is taught has to change. We need to have more history and philosophy, and not the sanitized history that we're given to students these days, but the real debates that went on when big decisions were made, usually by a show of hands. And of course, science shouldn't be decided on a show of hands. It should be decided on the evidence. But many of the big decisions have been made almost on the basis of show business rather than any real strong evidence. We were talking about Einstein actually, and before, and I don't think we've quite finished that one. I don't think Einstein was ready to discard his work, although he had been sidelined by his peers because he had, for most of his life, he produced some things early on which were given a showbiz welcome after the Great Wars, as they were called. And I think it was a case at that time, people were looking for an escape from reality, and we did it both in the arts and the sciences. We had surrealism. Salvador Dali was inspired by Einstein and painted his melting watches and strange landscapes. And I would argue that both quantum theory and relativity were born out of this escape from realism, because Niels Bohr wasn't interested in explaining quantum theory just to get equations that work. And this is still the state of quantum theory. It's like a recipe book with no understanding of why the recipe works. In Einstein's case, he tried to explain gravity in a way which cannot work. It doesn't explain what warp space is. Space isn't a thing, it's just a concept, so you can't warp a concept. And also you could say that his idea of relativity itself was a case of making something which is apparent to the observer and saying that's actually real. It's like watching somebody disappearing in the distance on the back of a train or a ship or something. And as they disappear in the distance, they shrink in size, and if we could hear their watch ticking, it would appear to tick more slowly just by the Doppler effect. What Einstein did in effect was to say those things were real when we know they're not. And of course, as soon as he did that, it meant that we departed from real physics and any chance of understanding gravity or quantum mechanics. It's funny. Just by doing that, he prevented quantum theory from having an explanation, because that requires instantaneous communication between separated matter, as seen in these so-called spooky action at a distance experiments. And this crazy word non-locality, all it means is instantaneous action at a distance. And Newton's law, of course, which, as I said earlier, is an instantaneous action at a distance theory, which Newton had the sense to say he didn't understand, but Einstein lost the plot and thought he'd explained it.
Now, when it comes to relativity, haven't they done experiments where they've shown that like clocks flying around the Earth come up at different times, and the ones sitting stable on the Earth?
Mm-hmm. Yes, they're talking about clocks, not time. You've got to make the distinction very carefully, because it's been found that subatomic effects on the Earth can be traced to activity on the Sun, instantaneous activity on the Sun, or the position of the Sun with respect to the Earth or the Moon. All of these things have been shown experimentally. So subatomic particles are subject to their location in space relative to everything else. So if you put a clock up in space above the Earth, then you have to adjust its rate of ticking, or at least allow for a change in its rate of ticking in the gravitational field. It's simply because the matter in the clock is now at a different distance from the matter in the Earth. But it has nothing to do with time. In the electric universe, there is a universal clock, if you like. There's universal time, and you cannot mess with it. You can't slow it down, speed it up. You can't time travel, which is unfortunate for the science fiction fans. But when you think about it, even the idea of an arrow of time is nonsense. The mathematicians often confuse the symbols with something that they make up. And that's the case with the arrow of time, because somebody once said, okay, if time has a direction, point me in the direction of time. You can't do it, because time is merely a concept of the intervals between two separate events. And Einstein confused the issue by saying that the speed of light was the maximum speed with which he could tell whether an event was coincident in time between two separated incidents. And once he did that, of course, this messed things up more than somewhat. So one of the things that comes out of the electric universe is that you realize that when matter is connected in real time, obviously it can't be an infinite speed, because infinite means nothing. It means that on our scale, maybe within this entire galaxy, you can expect that all of the matter is in touch with all of the other matter. And when you think about it, you couldn't actually form a spiral galaxy if the stars on one side had to wait 100,000 years before they knew where the stars on the other side were. You could not maintain a beautiful spiral galaxy, the most common form of what I would call a galactic electric discharge in the universe.
Okay, the theory of dark matter and dark energy is one of the things that they have created in order to explain how galaxies hold together. Mm-hmm. But the electric universe theory explains that in a much neater, simpler way, doesn't it?
Yes. Yes, there's a number of beliefs which have to be stifled. And I understand the difficulties in that, because when I came across these stumbling blocks, some of them took me a decade to let go of, these beliefs about how what's real and what's not in science. The thing is that if you use the Newton's law of gravity, and you look at the the orbits of stars around the center of a galaxy, you find that it revolves more like a solid disk than it does the planets in our solar system, where the inner planets rotate around the sun at a rapid rate. They have very short years, and the ones in the outer solar system, have years measured in decades on Earth. You'd expect the same would happen in the galaxies, but it doesn't. So it was decided that you could fix this and maintain Newton's law, provided you put a whole lot of mass, invisible mass, somewhere surrounding the galaxy in just the right places. But this is a completely ad hoc arrangement just to save your theory. That is, that Newton's law applies in galaxies. However, the plasma cosmologists have both experimentally and also in supercomputer simulations shown that the spiral shape of a galaxy and its rotation, even the fine detail in the rotation, is matched by an electromagnetic system where you have electric currents flowing along the arms of the spiral galaxy in towards the nucleus. And that, of course, also explains the super concentration of energy and mass at the center of the galaxy. So that doesn't require the invention of any mysterious dark matter. As for dark energy, this is a case where the expectations of the expanding universe weren't being met, and it appeared to be an accelerating expansion. So then some kind of anti-gravity had to be invented which could speed up the process. But that was all based on the standard candles they call supernovae. Supernovae are supposed to explode in a predictable way, and you can measure their light output and the curve of the light to give you the distance when you know the brightness of the supernova. And they found that the more distant supernovas seemed to be fainter than expected, which they interpreted as being further away than expected. And that meant that their theories of expansion had to be reinvestigated and rejigged. And as I said before, the problem with science today is that you're rewarded for inventing new forces and new particles instead of being asked to simplify, reduce the number of particles and forces. So this is what happened. But of course, no one understands a supernova explosion. No one has been able to reproduce it theoretically. And the explanation that's given for a supernova explosion that just doesn't work. But I published a paper in a peer-reviewed journal quite a few years ago now, and showing that it is simply another case where the electrical energy being fed into a galaxy also feeds the stars. And a supernova is like throwing a circuit breaker on one of those huge intercontinental transmission power lines. And you've probably seen the videos where if you throw the switch at the wrong time, this huge arc of electricity follows the switch all the way up and then extends out into the atmosphere for some meters. If it's been shown in plasma physics that you can form what's called a double layer, which can act as a switch. It can actually switch the current off, and if it does that suddenly, it's just like the intercontinental power transmission line. All of the energy in that circuit is concentrated on that switch, and if there's a hapless star at the where the switch is, which is normal, that star cops all of the energy in its galactic circuit in a very short interval of time, and of course the star goes berserk. But so the electric universe has an explanation. It also says that the supernovae are fainter in high redshifted objects, galaxies, simply because high redshifted objects are young, they are less energetic, and therefore supernovae are less energetic. There's no necessity to postulate the universe is expanding at a faster rate and needs dark energy. So all of these things become very simple.
Yeah. Yeah, and that's, I think, one of the things that impressed me so much is that it was so simple and it made so much sense. Let's bring things a little closer to home. Let's get into plasma discharges that may have been seen here on Earth, and mythologies and stuff like that, and the work of Anthony Perrott as well, if you don't mind.
Yes.
Now, Anthony has shown that a lot of the something like 80 different forms of ancient art are actually symbols of plasma discharge. And Robert Schoch, too, has pointed out that the Easter Island glyphs seem to be plasma discharges. And what does this mean? Why are all these plasma discharges showing up in ancient cultures?
Well, I think it's significant that to actually chisel in rock these petroglyphs, as they're called, is a considerable amount of work. It's not something you would do just to like doodling. And the very fact that Tony was able to find all of the, when I say all, there's about 84 different forms of a plasma discharge. It goes through a series of stages, and they take quite striking forms. And one of the most striking and perhaps long-lived was what's called the squatter man, where you have the central discharge, and then you have what's called a plasma disk comes out from the central discharge and then curls upwards. And there's one further along the axis which curls downwards. And there's one in the center which remains flat. Now, when looked at side on, plasma tends to be transparent, except where the energy is very high. So anyone looking at it side on would see what looked like a squatter man, somebody with their arms, their elbows out from their body and their arms raised up at right angles and their legs out at right angles also. But between their elbows and their knees on each side is this bright ring or dot. And you find this all around the world. And it is a classic form of a plasma discharge seen side on. But apart from that, Tony said that most of the other forms are also to be seen, except for a few which are related to a time when the plasma discharge is actually emitting lethal X-rays. So anyone standing out in the open chiseling on the rock would have been killed by the radiation. Right. And so he then found that these petroglyphs, he could actually predict where they would be found on a rock wall, because he said that they were looking at a part of the sky that was shielded by something on the horizon from the lethal X-rays. And also the X-rays, he said, tend to travel down canyons and that like a river, so you'd have to find a spot on the canyon wall where it was safe. But I think it also shows that whatever was happening, the ancient peoples we have no reason to believe they weren't as intelligent as we are. It was just that they were dealing with a situation that we would find absolutely horrific, the equivalent of doomsday. And they wanted to chisel their experiences for future generations if there were to be any. And this answers all kinds of questions, because it's known that civilizations sprang up seemingly from nowhere, and it was after this event. They all looked back upon these events in the past. They were a memory, and they memorialized what was seen in the sky in their architecture and their city layouts, that kind of thing. So it's interesting. I'm able to walk into a museum and look at ancient figurines and carvings and pictures and so on, taken from cave walls and that, and I can see what they're trying to tell me. And I think this is of profound importance. We have to pay particular attention to what the most ancient races on Earth still have to tell us, like the North American Indians and their myths, creation myths, the Australian Aborigines and their creation myths about the rainbow serpent that changed the landscape. All of these things right around the world. And this is what Velikovsky began to do, and other scholars who picked up on it have been continuing to do, and they're members of the Thunderbolts.info group, of course.
Okay, and David Talbot has done a lot of work lining up the mythology as well with what may have actually happened in the past.
That's right, yes. He and Eduardo Cardona and F. Cochran in particular have done amazing scholarship to try and piece together what the ancients were desperate to have us understand, and which we've studiously misinterpreted for thousands of years. But the picture that is painted is one which is just amazing. It gives you a whole new feeling for what our forefathers, our ancient forebears went through. and why they did the things they did, what motivated them to build pyramids that we couldn't even build today, and did this all around the world, and obelisks and so on. It throws our history into a completely different light. It's not the kind of once upon a time fairy tale that we're taught. You begin to understand what all these strange anthropomorphic gods and things were that were worshipped around the world, and why there was this feeling that the gods lived and fought and capriciously in the heavens. That's exactly where they were. And what these thunderbolts of the gods were. When you look at the carvings or the sculptures of Zeus and his thunderbolt, it's nothing like a modern lightning bolt, which looks like a spark. Zeus's thunderbolt has the form of a plasmoid, which is the form that you would expect a discharge to take place in space. So these are the kinds of things which give you pretty solid evidence that we have to take this this mytho-historical record, as it's called, seriously, if we're to understand our forebears, our real history, and our past. Because Velikovsky, in his, I think his final work, Mankind in Amnesia, felt that unless we understand our past, we will continue as a race to behave irrationally. And I mean, you've only got to look around for a moment to see just how irrational we are. The doomsday fear is unexplained unless you understand our real past. Our separateness, our desire to set up them and us, at odds with each other, and then to have this cathartic visitation of doomsday on each other by trying to destroy one or the other of us in our crazy wars. All of this stuff, when you understand it, Velikovsky felt that unless we understand it, we may not have a future on this planet. And I tend to agree with him. We have to understand our past, come to terms with it, and grow up.
Well said. Now, part of the reason we didn't recognize what these symbols, these petroglyphs, were is because until they were produced in the lab, we had never seen anything like it in modern times.
That's right. Yeah, Tony said when he came to our meetings and began to realize what he'd found, said that he went hunting around Los Alamos and he walked past the North American Indian petroglyphs and that without even realizing he hadn't stopped to think, that there'd be any connection between them and the work he'd done in his laboratory. And yet he was the expert, the world expert on these plasma instabilities, as they're called.
Let's look at, actually, Robert Schoch's theory that the sun had released such an outburst that it caused these plasma formations on Earth and ended the last ice age. Is that something that is realistic under the electric universe theory?
It's one of the things that has to be considered because the discharges, of course, occur along the magnetic field line, so you'll tend to see stupendous auroras if there's any electrical disturbance close to the Earth. And Tony Pratt actually used that in his peer-reviewed papers discussing this discovery. But the mytho-historical record, if you can call it that, shows that that wasn't the case. It wasn't the sun at all that was involved, that it had something to do with a chaotic stage in the solar system where certain planets were very close to the Earth in an alignment which is completely at odds with Newtonian physics, but which does, I believe, have an explanation when you understand the electrical nature of gravity. And that is one of the aspects of the electric universe. All forces collapse down to be explained simply as an electric force, which simplifies physics enormously and gives new understanding to quantum mechanics and to the mechanics of the universe itself.
Okay, when we look at Mars, you guys have done some fantastic videos showing that you can recreate in the lab exactly the type of scarring we see on the surface of Mars.
Yes, that's right. In fact, this is one of the big tests, is to be able to reproduce in the laboratory the scarring that you see on planets and moons, because these thunderbolts of Jupiter, if you like to call them that, although it wasn't Jupiter that was necessarily involved, are able to sculpt the surface of a planet in a very short period of time, measured in minutes and hours. That's why you can have some objects in the solar system with completely different scarring patterns on one face than the other. Our own moon is an example. But in Mars' case, it has one of the biggest gashes across its face in the solar system. The Valles Marineris is a colossal scar which stretches a third of the way around the planet and is up to 9 kilometres deep. I mean, it's hard to imagine. But the ancients actually described, have stories about Mars receiving that scar. Now, no astronomer on Earth imagines that Mars has a history which can be recounted in terms of a few thousand years ago, and also something as colossal as that scar on the face of Mars. But when you look at it from the electrical point of view, it just becomes obvious. In fact, one of the nice things about the electric universe is that it returns science to individuals who want to try things out in their garage or laboratory. And we have a number of garage experimenters who are producing detailed reproductions of, in miniature, of the things we see on the surface of Mars and other bodies.
Okay, what do you think what planet do you think caused the scarring?
Well, Mars was said to have been had a battle with Venus, the comet Venus, and I think that was the most likely where the thunderbolt came from. Venus itself has scars which stretch around the equator, but they're more filamentary, and that's the kind of thing that happens when you have a thick atmosphere. The lightning becomes not the plasma form that you see in space, but it becomes the lightning form you see in the Earth's atmosphere, thin filamentary lightning bolts. And that's what you see on Venus, scars stretching around the equator. So Venus was certainly involved. The Earth was involved too, because Mars traveled between Venus and the Earth. At times it was regarded as a giant in the sky, the god of war, and at other times it was a baby returning to the womb of the mother goddess, Venus. The stories like this tell us all sorts of details about what went on, and you can reconstruct an incredible amount of what actually happened. But Mars was transferred both matter and electricity between Venus and the Earth. And the very fact that meteorites from Mars are still landing on the Earth today is significant, because these thunderbolts just rip material from the face of a planet and hurl it into space. Some of it may be trapped as a moon, and Mars has 2 small moons. Others become asteroids, cometary material, and meteorite or meteors, which then become meteorites when they enter the Earth's atmosphere.
Now, do you think that the asteroid belt came about because of this collision?
Yes, the astronomer Tom Van Flandern pointed out that the orbits of the asteroids and comets as well suggests some event that occurred in the asteroid belt region. And he thought it was a single event, or it may have been maybe 2 events, something like that. But the result is that it stripped whatever it was. He thought it was the collision or the explosion of a planet, but he never explained how you explode a planet. The electric universe doesn't need to postulate that. It has eyewitnesses which described what happened to Mars, and it is obvious that it had material ripped off its surface, some of it kilometres deep. So that a lot of the debris out there is material excavated from Mars. And it should be very easy to test this once we begin landing on asteroids and taking samples and so on. And then the real history of the solar system will begin to be uncovered.
Well, do you think it really will, or do you think they'll come up with alternative explanations?
Well, I think eventually I have confidence that the truth will come out. And I mean, when you stretch your theories with ad hoc additions and more barnacles, eventually the whole thing sinks, can no longer float. And I think that will happen. Also, I think people will begin to get sick of the science fiction type headlines and promises and that from science. It could be said that fundamental science hasn't progressed anywhere in the last century. Technology has progressed amazingly, but it can work without actually understanding things. It just needs proof in the laboratory that something can happen, and then you can utilize that in industry, perhaps, or some kind of new device. And this happens in quantum mechanics, of course, because our electronics relies on quantum theory, but quantum theory has no explanation. So technology advances even with the fundamentals of science doesn't.
And this is why we can put spaceships in orbit and stuff, because the formulas work, even if we don't understand why they work.
Yes. We use Newton's law for navigating around the solar system, but no one understands it any more than Newton did.
So Velikovsky's idea that Venus was the one that slammed into Mars and did all the damage and stuff, do you think that's probably correct?
Well, yes, to a point, except that the planets don't slam into one another. When they get close enough, the thunderbolts themselves exchange energy, which then changes the mass of the planets, so their orbits gradually move into situations where they interact with each other the least. There is no explanation for why the solar system runs like clockwork, because Newton's theory suggests that the whole thing should be chaotic, but it's not. And also, Venus has the most circular orbit of any planet in the solar system after having been, according to our ancient forebears, a giant comet. The answer is simply that a comet is exchanging electric charge with the solar wind at a huge rate, and that's why you can't predict the return of a comet, because it has these so-called non-gravitational forces. Well, Venus is the most circular orbit because it's still discharging, but invisibly. But in the old days, it must have been a phenomenal sight.
I was pretty impressed with Laird Scranton's book on Velikovsky, where he took modern science and showed that none of it disproved Velikovsky, but a lot of it supported him.
That's true, yes. In fact, Velikovsky didn't depart from the scientific method at all. What he did was he said, if we look at what the ancients were trying to tell us, we can, with our modern knowledge, figure out what that meant physically on Earth. And he did that and showed that it made sense, which indicated that the stories were not simply myths or legends or something that we could ignore. We had to take them into account and find explanations. And that was the start of, for me, in fact, when I visited him at his home just before he died, my question was, what don't we understand about gravity? And it was he who put me onto the idea of polarized matter, electrically polarized matter. And that sort of led on over many decades to where we are now with the electric universe model.
Now, if there had been life on Mars back in ancient times,
yes,
would there even be any remnants of it after a interaction with Venus?
That's a very good question. But I think since kilometers of material has been removed, particularly from the northern hemisphere, you won't find anything there. And I try and imagine what it would be like if the Earth had suffered the same fate and whether we'd actually find any trace of our civilizations. And I think it would be very difficult. You'd have to be extremely lucky.
Well, how close did other planets come to the Earth, do you think?
David Talbot estimated from his work that Mars at one point was 40 times the diameter of the full moon.
Oh.
Which would be oppressive, to say the least.
Yeah. And what's the time frame in the past we're looking at for this?
Well, this is where we depart from Velikovsky, who brought it down into historical times, 1500 BC and so on. Mm-hmm. We're looking at the end of the last ice age, which is variously dated around 10 to 12,000 years ago. But there may have been, after those major events, there would have been a lot of settling down afterwards, and there must have been some colossal, spectacular comets and things like that, debris flying around, which must have scared our ancestors even down into historical times. So there were echoes, I think, because every time these things happened, we still have that fear of comets. It's quite irrational because no one's ever witnessed anything happen as a result of the comet. And the comets don't put on that greater display these days. But it's a hangover from our past. It's kind of a racial memory, like a bird freezing at the shadow of a hawk overhead. We tend to freeze at the sight of a comet.
So what was the configuration of the solar system, do you think, before the end of the last ice age?
We wouldn't, if we were transported back to before that time, we would not know where we were. We'd have no references like we have today.
It would be that different. So, like, would we have the same planets?
No.
Okay.
One of the things about the electrical model of gravity is that capture of planets and moons is far more likely because you get electrical transfer of between the objects, and that modifies the orbits in such a way that capture is likely. And it seems that all of our gas giants in the outer solar system are captured because when we look at exoplanets around nearby stars, they have what are called hot Jupiters, these planets that are orbiting very rapidly around a central star, and they're very close to the central star. Those ones, I think, are probably due to electrical fissioning, so that you get multiple star systems of close orbiting bodies. Gas giants that are some distance away from the central star are the remnants of brown dwarfs which were captured by the sun, because a star is an electrical phenomenon. That's one of the other big hurdles that astrophysicists are going to have to face with our work, is that it seems that the lightning bolts that form stars also continue to power them invisibly with these Birkeland currents throughout their lives. And so if a faint star, a small star, comes close to a bright star, the bright star captures it and it switches off the small star because its power is no longer available. And astronomers know that there's what's called a brown dwarf desert around bright stars. The simple answer is that they're switched off when they come in and they become a gas giant. So all of the outer solar system giants were captured, and in the process they lost some of their moons, which became the planets in the inner solar system. And so everybody in the solar system has a unique story to tell, and some of them are family members and others are not. So there's a complicated story to untangle for future astronomers and those who visit the planets.
Okay. I've been wanting to ask you this one. Are you familiar with Walter Cruttendon?
I've heard the name, but I can't remember what he was responsible for.
Okay, he has a book called The Lost Star of Space, Lost Star of Myth and Time, or something like that, and he's pushing the binary star system, that we're in a binary star system. And one of the possibilities he suggests is that we're in a binary star system with Sirius. Now, would an electrical explanation connect us to Sirius? Like, because the argument is always that gravity isn't strong enough to hold Sirius and our sun together. They're too far away.
Yes.
It would.
Yes, that's right. It's Sirius is not a binary with us. It has its own partner, Sirius A and Sirius B. It's got nothing to do with us. The idea that there's a dark star ready to come in and create havoc is another manifestation of this doomsday fear. Something out there ready to get us. We would have discovered by now, I think, if there was a brown dwarf of any significance close to the solar system, because we've got these wonderful infrared telescopes in space which have been able to detect very faint glowing objects at much greater distances than a binary partner for the sun would be expected to be found. So I don't think there is a binary partner out there. However, the story of the Earth and its involvement in capture with a brown dwarf suggests that these encounters, and the fact that we have more than one gas giant in our solar system, suggests that these encounters do happen and can happen again. But let me tell you, if it does happen, we will have plenty of forewarning. because
Right.
because one of the things that the captured brown dwarf does is it turns into a phenomenal stellar-sized comet.
Now, when you talk about Brooklyn currents powering the stars, are these almost like invisible strings running through space?
Yes, they become visible in molecular clouds, and this is one area where the infrared telescopes have been valuable because they've been able to pierce through the dust and the gloom and show that what you have in molecular clouds is like you have clouds on Earth, and that is lightning bolts. And the stars form along those lightning bolts, like beads on a string, it was said in one of the astronomy articles. Of course they're like beads on a string. It's almost a form of bead lightning. And the plasma cosmologists have described how stars are formed in those circumstances. And the important thing to note is that it preferentially puts all of the heavy elements at the center of the star, and the center of the star is the coolest material in the star. So there is no nuclear fusion going on in stars. So when you look through a sunspot and it's dark, it's because there's nothing going on underneath. I mean, this simple fact should have been obvious when we first looked at the sun, because if the energy is trying to escape from the sun and you have a hole in the photosphere, you're expected to be blindingly bright instead of dark. So this is another hurdle for astrophysicists in the near future.
Okay. You also had an explanation for the odd storm on Saturn's pole.
Mm-hmm. Yes, as I said earlier, the electric currents that flow to a planet, because a star is connected to a galactic circuit, the planets that orbit it are also kind of involved in that circuit, so they get some of the power. In the case of the gas giants, they get considerable power, and it flows in along the magnetic field lines to the poles. Now, there's very strange things going on, have been discovered at Saturn's pole. One is a hexagon, and another is a cyclonic circulation at the pole itself, and also the fact that the pole was found to be warm, although it had been in darkness for 14 years. I predicted that would be the case because this is where energy is being fed down into the atmosphere of the planet. And the hexagonal pattern is one which forms when you get particle beams in the laboratory. It tends to form filaments, if you like. Instead of being a single beam, it breaks up and forms a number of beams, and it can be 4 or 6. And 6 particle beams will form a hexagonal shape in the atmosphere of Saturn.
Okay. You think there's any chance that there's like a black project out there that's using these theories that we would never hear about?
I have no idea. It depends on the extent to which some scientists are willing to let go of what they believe and try things which are so-called on the fringe. In our case, I could see people reading, because I'm free with this stuff. I put it up on my website, holoscience.com. It could take this and run with it. And I've often felt that some small nation that has no attachment to the myths and legends of Western science could see the opportunities, because there are a lot of opportunities that open up in the realm of energy supplies, low energy nuclear fusion, anti-gravity, all this kind of stuff can be investigated scientifically once you have a model to work on. You know, once you've got a model of how things work, you can then devise experiments and think up ways and means of utilizing it technologically.
And it just occurred to me because, I obviously the U.S. government has done work with remote viewing and things like that,
yes,
that they say don't work. So why not take a theory like yours? And they didn't have to tell anyone they're using it.
Well, you begin to realize that, as I said earlier, the fundamental idea in the electric universe that all matter in the universe is connected, and it's connected electrically by the electric force, and matter which operates at the same, operates internally at the same subatomic frequencies, actually can communicate instantly. So you don't have the speed of light delay, and it raises the possibility of interstellar communication in real time. It also, you can understand how ESP can work, and also work in a Faraday cage, because it's just like gravity. You can't shield from it. The gravitational force is one aspect where the planets know where the stars are instantly. So in effect, ESP is like one person's mind being able to investigate something at a distance, because it's connected in a sense. It also explains why quantum experiments are so weird. It's because the observer is not separate from the experiment. They're all connected. So all the spookiness and weirdness of quantum theory goes out the window and becomes understandable. Once you have an understanding, then the future of science is pretty rosy, because all kinds of possibilities open up. And in fact, it's a bit like Arthur C. Clarke said, any sufficiently advanced technology, which would have to be built on an advanced science, is indistinguishable from magic.
Yeah. All right. So if people want to find out more about your work, what's the best way they can do that?
Well, my website is called HoloScience, HOLO science.com. And the reason for that is that it's a kind of holistic approach to science. It's a coherent big picture. The website which deals with the public far more is our thunderbolts.info website. And from there you can find out about our conferences, and you can get involved in discussions with others, and also you can get involved to any level you like. We have a lot of volunteers now who do sterling work in allowing us to present our material.
And you also publish a good deal of videos.
Yes, that's the other thing. Our conferences, we're getting more and more scholars coming along and finding that their work dovetails with ours, and their presentations are put up as YouTube videos following our conferences.
Okay.
I also have the space news, which I do regularly, where I give my take on recent discoveries.
Okay, and you also have some DVDs out?
Yes, and they can be also found on that thunderbolts.info website.
And how many books do you have?
Well, the two major ones at present are The Electric Universe. Dave Talbot and I co-author our books. His work is more on the mytho-historical record, and mine is on the scientific. And the first book we put out, Thunderbolts of the Gods, deals with the record of the ancients and piecing that together in terms of the astronomy and also the plasma effects. The Electric Universe talks about the electrical nature of the universe. I have plans to put out another book, which I'm working on at present, which will give a kind of simple big picture story of the Earth and the electric universe.
When do you think that might be available?
Difficult to say. It depends on how many requests I get to either speak at conferences or do other things.
Okay, and do you have any conferences coming up?
Our big annual one was in March, so there are YouTube videos going up right now about that one. My next conference is the Nexus Conference here in Australia at the Sunshine Coast in August, first week of August. And that can be found also by a Google search. Okay.
All right. Well, I thank you so much, Wallace. It's been fascinating talking to you, and I hope people check out your stuff. And there's so much detail on your sites that people who have further questions who want to delve into it deeper, you make it very easy for them to do it.
Mm-hmm. Thank you.
All right. So, as I said, we're going to be talking here with Wallace Thornhill. Hello, Wallace. How are you doing?
Hello, sir. I'm fine, thank you.
And you are still in Australia, right?
Yes, for the moment.
And next, it's next month now. You have a conference in Arizona.
That's correct. 25th to 29th of June. And it's at Phoenix.
Okay. And that is the Electric Universe. This is the big conference you do every year, right?
Yeah, the Thunderbolts conference, which is based around the Electric Universe.
Okay. And how many years have you been doing it?
Let me think. I think this is the 4th year.
Oh, is that it? Seems like you've been doing them longer than that.
Oh, yeah. Prior to that, we had a lot of meetings, which were sort of ad hoc. But these, having one every year, gives people an expectation of being able to meet up and chat at least once a year.
And who do you have at this one?
Wow, we got quite a lineup. Apart from Don Scott, who's the professor of electrical engineering and has been working on the electric sun, electric sky. His book is called The Electric Sky. My colleague that I've worked with since 1997 is David Talbot. And we have Professor Jerry Pollack. We'll be talking about beyond water, what makes the world go round, talking about the 4th state of water and its critical nature for life itself. Montgomery Childs, who's an engineer who ran a big engineering company and is now the head of our Sapphire project, which is looking at proving the electrical model of stars. We've got Ben Davidson from, he runs the show Suspicious Observers on suspiciousobservers.org and looks at the electrical nature of earthquakes. Does the sun trigger large earthquakes? Dr. C.J. Ransom, who's a plasma physicist and who I've known for many years, will be looking at, called Close Encounters of the Star Kind is his first talk, and talking about the idea of uniformity being used to support the claim that mythology was only created in the minds of the writers. He'll be showing that that's not true. We've got Dr. Franklin Anariba, who'll be talking about the electrochemistry of comets, since comets are an electrical phenomenon. Michael Steinbacher, who's interested in plasma catastrophist geology, and that is the formations we see, particularly in the US Southwest. And he talks about them in electrical terms. Dr. Tom Wilson, who'll be talking about the siren song of certainty, which shows the rather odd way that science or human beings behave anyway when doing science, and that is they're attracted to a kind of groupthink and the difficulty that we have these days because of the institutionalization of science in breaking free from that and actually introducing really new ideas. We've got a number of other people. Dr. Bruce Laybourne will be talking about climate change and the Earth as a stellar transformer. With Eduardo Cardona, who's written the definitive works on the earliest memories of mankind and the history of the solar system. Dr. A.P. David, talking about the metaphysics of Michael Faraday. And Ignacio Cisneros, who's a very good friend and who's doing amazing work in analysing images from space and looking at the filamentary structures which are indicative of electric currents in space. Ev Cochran, who's a colleague of Dave Talbot's and has been for decades, looking at planetary catastrophe in terms of ancient myths and modern science. We have another chap who I haven't met yet, talking about solar system formation. And Dr. Pierre-Marie Robitaille, now he's doing very important work, looking at Kirchhoff's claims about thermal emission and showing that Kirchhoff's laws are actually mistaken. And not only that, Max Planck's trying to claim that Kirchhoff's laws are universal is incorrect as well. He's working with Stephen Crothers, another Australian, a good friend, who looks at general relativity and a case study in numerology and shows that the mathematics behind it is flawed. And anyone who's followed it since and claims to understand it, their mathematics also doesn't come up to scratch. We have Reverend Robert Straight, who's a PhD in chemistry in engineering, revisiting our understanding of classical physics and relativity, because this is obviously one of the big themes. We've got Dr. Gary Schwartz looking at extraordinary ideas and extraordinary evidence, and he's done amazing work at the University of Arizona. A couple of other people I haven't met before. Richard Moore's talking about the pulsating universe and planet Earth, looking at electrical the spiky nature of electrical current and its implication in terms of cataclysm and ice ages and climate. Wayne Byrne, I haven't met yet, talking about the structure of interplanetary discharges and the effect that has in cratering, and showing that impact craters can only have been made by lightning bolts. We've got another chap talking about plant electrotropism, and this gives you an idea of the broad range. Once you are looking at the underpinnings of science, and cosmology is supposed to be the queen of the sciences, the umbrella under which all of the others fit, once you start producing a new cosmology, then it has effects right across science and also culture, cultural activities. So we have artists involved at various times. Michael Armstrong's talking about the culture shock of planetary catastrophe, and then we have David Novak, who's our master of ceremonies and an amazing guy. His ability to weave together the disparate subjects and talks and speakers is quite something to behold. He's quite a performer on his own. So it's going to be a great show.
It sounds like it. My God. That is one hell of a lineup. And how many days is it?
Well, the 25th to the 29th, so it's 4 days.
Wow.
I think. Yeah, actually, the first evening, of course, is open to the public, I think. So anyone who wants to come and have a listen can get some ideas of what's happening over the following 4 days.
Okay. And who puts this? I mean, I know you have a part in putting it together. Is it mostly David Talbot out there kind of putting the details into everything?
Oh, we have a great team of volunteers now, and without them, this would not be possible. And in particular, we have somebody managing the conference, Susan Shirot, who's quite an amazing organizer. And we expect to be doing live streaming on the web this year for the first time. We have people involved in that activity who have shown themselves to be extremely professional. So we're looking forward to this first for the Thunderbolts conferences.
Wow. Okay. And that, I'm sure people will be able to find more about that at thunderbolts.info?
Exactly, yes.
Okay, and that's where you can go for all the info on this conference, as well as you guys put so much stuff into that site. You have a video of the week that comes out. I mean, there's just so much information that's on a constant stream out of there from so many different people. It's utterly fascinating.
Yeah, it's so easy because science is reporting surprises almost on a weekly basis, so we've always got more material.
And a lot of these surprises aren't surprises to you.
No, this is the encouraging aspect of the electric universe. We're open to new ideas all the time. But these surprises, as they come in, we have a look to see how it fits with the big picture, as we call it. And we haven't had any difficulties at all fitting these surprises to the electric universe cosmology, which is, of course, how a replacement cosmology must operate. It must be able to explain things better than the old one.
Right. And as an example of that, do you want to explain a little bit about Comet 67P and what they expected versus what you guys have been saying about comets all along?
Yes, well, back in at the turn of the 18th, 19th century, scientists were talking quite openly then about the electrical possibilities of comets. But that all got squashed for some reason or other, and the history of these ideas is always very interesting to trace because you often find where we make the big mistakes. And the big mistake was made when it was decided that electricity played no role in cosmology. And that is a quite amazing thing to do because electrical power, we just can't do without it in modern science and technology and day-to-day living. And yet it doesn't play a role in cosmology. And yet the electrical force is so much more powerful than gravity. I mean, gravity is so weak that it's essentially zero compared to electricity and magnetism. And yet here's this almost zero force being given as the driving force in the universe. And this, of course, is why we end up with black holes and, these monstrous things that gobble everything up, because gravity is all they've got to work with. All they have. So anyway, getting back to comets, it was recognized early on that the features of a cometary display were similar to those seen in the old gas discharge tubes. This glow that you can get in a low pressure gas. And of course, the solar system is an extremely low pressure gas. The flaring of comets is also an electrical phenomenon that you see on cathodes when they light up. And the jets also, cathode jets, is the kind of thing that they use in industry in spark machining. And this has been recognised too by people in the industry who've joined us, that all of these features make sense from the point of view of electrical discharge machining. Now, so when we look at the jets on Comet 67P, we are not expecting ice to be the responsible for it. In fact, it can occur from high points, sharp points, and so on. And this is what we've observed in the past, that it's the sharp edges of craters and things on a surface which tend to get eroded away. The other thing about Comet 67P, and this gets down to our complete lack of understanding of gravity, is that its gravity suggests that it's a kind of fluff ball. It's not even solid ice. It's must have a lot of empty space inside, so it's porous. Well, when you look at Comet 67P, it looks like a piece of rock. And my suggestion early on was, if it looks like a piece of rock, then that should be your first assumption, that it is rock. But of course, the gravity says, no, it can't be. But when you understand the electrical nature of gravity, because gravity is, in effect, in the electric universe model, a very weak dipole electrical force that's down at the subatomic level. That's why it's so weak. It's the kind of effect from electrons and protons and neutrons, the bits that make up atoms. And a comet is in a very odd environment. It's quite different to the Earth. It's in the sun's environment. There are no large bodies nearby to affect its atomic structure. So it has a very weak gravitational field, but that doesn't mean that it's not made up of rock. And also, being in the sun's electric field, as it travels rapidly, more and more rapidly towards the sun, its electrical environment is changing, and in response to that, it begins to discharge. And that's, of course, is what we see.
Okay. And the established view of comets is pretty much that they're just dirty balls of ice.
That's right, sublimating gas, and the gas is blowing material off into space. But if that was the case, you would not expect to see these very fine collimated jets coming off the surface. Because if you blow a hole in the surface and there's material underneath trying to escape into space, it'll do so, tend to do it in an explosive way. In other words, you won't get a fine jet. That would only happen if you happen to be machining nozzles for jets on the surface of the comet, and there's nobody there to do that.
So the official explanation of comets, if I'm not mistaken, is that they are left over from the creation of the solar system. They are out in the Oort cloud and occasionally get knocked loose and come into the inner solar system.
Yes.
Where would you say, what are, in the electric universe theory, what are comets and where do they come from?
Well, the standard story is based on the idea that the Earth and all the planets and the Sun were formed from a rotating disk of gas and dust. That theory has never been shown to work. I was at a meeting of astrophysicists a year or so ago, and an expert on solar system formation admitted that you needed a different theory for every planet. And that's the clue. In the electric universe, stars and planets, the large ones, are built in effect in a cosmic lightning bolt in a molecular cloud. And this is exactly what the infrared telescopes like Herschel has observed. And the surprise expressed at the time was that the stars appeared to be like beads on a string, on a glowing string. Now, this doesn't fit accretion theory at all, but it does fit the plasma cosmology and electric universe model precisely. Now, under those conditions, you form planetary systems by bodies in that lightning bolt. After the lightning bolt fades, They then capture one another to form systems with multiple stars and with multiple planets. And the surprise expressed by those who have looked at, by now, more than 2,000 exoplanetary systems is that none of them seem to make any sense according to the standard theory of how the solar system was formed. In fact, we look like the odd one out. Now, this is a sure indication that your theory is failing. But science doesn't operate on failing theories. What they do is they get more and more complicated answers and keep the same theory. Anyway, in the process of capture, bodies have to adjust electrically to their new environment. And in doing so, they often have to eject material, because one way of achieving electrical stability is to just get rid of a part of yourself, get rid of that charge, which is charged matter. And so comets and asteroids and all the debris floating around in the solar system are the remnants of previous capture events. And the solar system, because all of the gas giants are at a great distance from the sun, must have been captured. None of them have any relevance to the formation of the sun. They were captured later. That's why it's such a fruit salad of objects in this solar system. And the electric universe story, which we'll be talking about at this conference, is what happened in the last episode of capture, because that impacted humankind dramatically. And we still haven't recovered from the after effects, psychological after effects of that.
Now, is that the end of the last ice age?
Yes, the ice age was part of it. In fact, there is no climate theory that explains ice ages.
Right. Now, do you think there was a shift in the poles? What do you think happened at the end of that started the ice age and ended it?
All of the evidence points to the fact that we were part of the captured bodies in the last ice age was part of that phenomenon. The story is, it would out science fiction any science fiction story, simply because, as often happens, fact is stranger than fiction. But we have all of the evidence in place now to be able to quite confidently point to the last phases of that capture episode in which the Earth was involved. And the ancients recorded at that time these thunderbolts of the gods, as they called them, these interplanetary discharges, and that's the origin of the material that's floating around in the solar system now. In fact, that's the very reason why Martian meteorites are still landing on the Earth.
Okay, so we were captured by the solar system.
Yes.
Now is this the Saturn hypothesis here?
That's right. We call it the proto-Saturn story because Saturn, in its former existence, outside the sun's electrical environment, was a brown dwarf star. And it's fascinating that in recent years, astronomers have finally come to the conclusion that life would be well suited to begin around as a satellite of a brown dwarf.
Okay, and when it got into the sun's environment, it lost some of that charge.
Well, in the process of capture, Proto-Saturn would have been a phenomenal comet of its own. And the discharges involved in that one would have been quite amazing. And this is the kind of thing that's been recorded around the world in petroglyphs. And that was a critical moment in our development of this work, was the coming together of high-energy plasma physics and the mythological evidence of these interplanetary discharges. I made the initial connection with Dave Talbot back in 1996, 97. And that's when we realized that the convergence of the science that I was doing and the reconstruction of the mythological stories, the global mythological stories, was the thunderbolt. It was the electrical interaction. And of course, when that was established, it became obvious to me also that in Australia, our Aboriginal people here have legends of the Lightning Brothers, and their depictions show things which you'd expect from the high-energy plasma lab experiments to exist, but which they could not have known about. The very fact they describe these things is very strong forensic evidence in favor of the work that we're doing.
Can you give us sort of an overview of what would have happened?
Yes, provided you don't, disbelief doesn't cut in and you just listen.
Mm-hmm. No, that's fine.
Okay, we were a part of a brown dwarf stellar system, and Saturn, or proto-Saturn, which would have been a larger body than it is now, was our sun, if you like. Now, if you could imagine Saturn or Jupiter today, and if their magnetosphere was lit up, you would see something, for instance, with Jupiter, if its magnetosphere lit up when we were closest on the same side of the solar system as Jupiter, we would see Jupiter as big as the full moon. Now, that is the extent of its electrical environment. Now, a brown dwarf has a very large electrical environment, much larger than the central body. Just like the sun has its electrical environment extends out 100 times the distance of the Earth from the sun to the heliosphere.
Right.
But in the case of brown dwarfs, this electrical environment is lit up as a glow discharge, so it glows red. So brown dwarfs, although they're small stars, actually their glow is much larger than the star itself. And if you can imagine, if you're on any of the moons of Jupiter or Saturn, you would be inside that red glow. And it's known that if you are inside a glowing shell, it doesn't matter where you are inside that shell, you will receive the same amount of energy on your surface, regardless of where you are, how you're moving, and so on. So the Earth at that time had a very benign environment for life, and there was no latitudinal difference. In other words, the poles were as warm as the equator. There was no night and day because the light was switched on all the time, if you like. We're inside the light. And so there was no such thing as night or day. It's interesting to try and speculate on how that must have been. But the light was remembered as dim, and it was purplish because you get both the red end of the spectrum and the blue and ultraviolet in those electrical systems. So it was the purple dawn of creation as it was remembered. Now, as Saturn came close to the sun's electrical circuit, it began to suffer adjustment problems. And this is one of the things that's been noticed about brown dwarfs and has puzzled astronomers, is that they tend to flare. That's their only way of adjusting to their environment. So proto-Saturn flared up, and that was the sudden brightening, this let there be light, Suddenly everything lit up brilliantly. And this glow tended to clear somewhat. And as we drew closer to the sun, proto-Saturn itself, the actual physical body proto-Saturn, developed a shining crescent on one side. And because at this stage, proto-Saturn was under this electrical theory of gravity, it tends to get accelerated towards the sun, away from its satellites. So the satellites were strung out behind it, rather like the comet Shoemaker Levy 9. And we were sitting in the cometary tail of proto-Saturn. The plasma environment there was recorded by the ancients, and they saw these what's known as plasma instabilities, and there are about 80 of them, but they recorded most of them. The ones they tended not to record were the ones that were lethal. In other words, the plasma discharge itself was emitting X-rays of such intensity that anyone out in the open trying to chisel into the rock what they saw in the sky wouldn't have lasted very long.
Right.
All of this became evident once we teamed up with the plasma physicists. So the proto-Saturn was captured by the solar system. In the process, of course, it would have had to have reasonably close encounters with some of the other bodies in the solar system, and the principal one would have been Jupiter. And it's possible that Jupiter was responsible for dislodging the Earth from this unstable arrangement of planets strung out in a line. It's interesting that Venus was observed as being born as part of this phenomenal discharge from proto-Saturn. And so Venus became the archetypal comet in all of these ancient stories. In the case of the Australian Aborigines, that was the rainbow serpent that sculpted the surface of the Earth. So these things are really, they sound like total fiction, but we have an enormous amount of evidence in favour of them. And what's more, the predictions and the expectations that come from this new cosmology are being met regularly with new discoveries.
Now, how long ago would this have occurred?
This is a difficult one, but the last ice age was part of the process. So you're looking around 12,000 years ago, something like that. But of course, the process of adjustment, although it was rapid because there was electrical exchanges involved in transferring energy, and that's part of the stabilization process. That's why the solar system looks like clockwork today. The whole thing seems to have taken place around 12,000 years ago, 10 to 12,000, but there would have been repercussions, with objects flying around and creating havoc and fear in mankind of another near total wipeout. That was our fear of doomsday. That's where it comes from. And it seems that we still suffer from it today because we seem to always need to have some kind of disaster in mind, which we're all going to die from unless some miracle occurs or man can find out a way to fix it. And the climate change is the latest one. It's funny to realise that it's only a few decades ago scientists were telling us we're in for a new ice age.
Right.
But since they don't understand ice ages, that prediction was false as well.
So what was the ice age?
The ice age was known as, it was the Fimbul winter of the Nordic gods. It was the twilight of the gods. It was when we were lost touch with our former sun. And it's interesting that the words for Saturn, the names for Saturn are the ones that we now have transferred to the sun, like Sol and Helios were originally the names of Saturn. It drifted off and became just a speck of light in the sky, and we had to find our new home in the solar system. That involved electrical adjustment of our orbit, and also Venus. Venus had to find its place. So between Mars, Earth and Venus, there was a lot of activity until we settled down. And so those repercussions would have lasted over thousands of years, possibly down into the era before, around the time the pyramids were built and so on. All of those major undertakings were in response to man's desperate need to try and establish control over nature again. That was the driving force behind all of that monumental architecture and so on, and worshipping of gods and whatnot.
What about Göbekli Tepe?
Yes, it shows signs of having the same origin.
Okay. Do you think they were recording devices or worship devices?
No, I think in each case it was an attempt to try and, as man has a tendency to do, try and gain control over nature. In this case, all they could do was to try and mimic what they'd seen in the sky, as if that would somehow appease these out-of-control planetary gods.
So, was in the electric universe theory, you comment on the connections to mythology. Was there a cosmological event that was recorded cross-culturally?
Oh, yes, this is the whole thing. Forensic investigation requires that you treat all evidence from different cultures as you would from unreliable witnesses in a police investigation. But the amazing thing is that when you use that technique, you find that there certain themes occur, doesn't matter where you look around the world at these ancient cultures. And those ones are the ones that you can be fairly certain. In fact, they're the ones that I've used to try and reconstruct the cosmology of the Earth, the solar system, and how it all works.
And what themes were these? Well, can you give not either pick one particular culture or a general overview?
Oh, no. The most ancient ones are the ones that we pay most attention to. And any references to what they said or wrote or chiseled into rock is what we use. In fact, the petroglyphs, which are prehistoric, were some of the most telling evidence that we could find for what we reconstructed independently of the plasma physicists. So that was really, I think, that was where the convergence really began to solidify into a coherent theory, both scientific and cultural.
What did the petroglyphs show?
Sorry, I didn't hear that.
What did the petroglyphs show that were chiseled?
Oh, the petroglyphs show, for instance, the squatter man symbol. Now, the squatter man looks like a chap with his legs and arms out at right angles, arms upraised and his legs stretched out. And the odd thing is that between the elbows and the knees, there is often a spot drawn or a circle. Now, the hourglass shape, which is what the squatter man is, a representation of looking through a plasma discharge from side on, that has that squatter man shape. It has the raised, it's like an hourglass, with the top part is stretches out and upwards and the bottom half stretches downwards and outwards. But in the plasma discharge, you have a circle of plasma around the center. And that appears, when you look at it edge on, as two bright dots or circles between the knees and the elbows, if you like. Now, this is repeated around the world, and there are hundreds of thousands of these petroglyphs dotted around the world. And so a study was begun by the chap who was the Tony Peratt, who was the expert in plasma instabilities. He'd studied them. And so he began an investigation utilizing the help of volunteers in various countries, including quite a few here in Australia, of recording photographically and with GPS the position and the magnetic orientation of these things, with the aim of being able to reconstruct in 3D the appearance of these things in the sky.
Wow. Okay.
All right.
And that study showed what?
Well, one of the interesting ones that came up in the early studies was that you have a radiating circle pattern which was used by the North American Indians, and it was possible to show that we had here in Australia a similar, well, it was almost identical pattern, but it was offset, as you would expect, from the two different points of view on the Earth's surface. So in other words, what they were representing was something seen in the sky from two different positions on Earth.
Wow. Okay.
And those patterns were those of a plasma discharge.
You've just given us an overview of the concept of the destruction that happened at the end of the Ice Age and what and us being attached to Saturn and so on and so forth. This wasn't something you came up with overnight. This was something that slowly developed over a number of years.
Oh, yes. Decades.
And some of this started with Velikovsky's work too, didn't it?
That's right. In fact, I give credit to Velikovsky for having introduced me to the forensic style of investigation of ancient stories from around the world. And his idea that Venus was a comet within the memory of mankind, and my great interest in astronomy as a student at high school really inspired me to read more. And it resulted in meeting up with him, actually, just a few months before he died in 1979. I was working for the Australian government in Washington, D.C., and I called his home, and he graciously agreed to meet with me and my family. And so I drove up there in 1979. I think it was in April. And I think he died in November of that year. But my question for him at the time was, if Venus was a comet in man's memory, then it's quite obvious we don't understand celestial dynamics because you wouldn't end up with the clockwork solar system you see today.
Right.
And I said to him the biggest problem that he faced with having his ideas looked at seriously by scientists was that it appeared to disobey Newton's laws, Newton's law of gravity and so on. And so I said to him, what is it we don't understand about gravity? And he climbed the stairs to his library and came back with a slim volume that he'd written back in the 30s, I think it was published in the 40s, called Cosmos Without Gravitation. And he said it was a preliminary work and he didn't want it widely distributed, but he gave it to me. And in there was the idea that gravity had something to do with normal matter and the separation of charge within normal matter. Now, this happens as a regular, this is the reason we exist, is that atoms distort when they come close to one another and they form these molecular bonds. And quite a lot of them, most of them, are these distorted atom-type electrical bonds. And so he said it was something along those lines, and there were a lot of ideas that put forward which interested me. But that meant that I had, if you like, a prepared mind, because 2 years later, I think it was, in the Scientific American in 1981, I think it was January, there was a tiny advertisement for the Journal of Classical Physics, and the chap responsible for it was Ralph Sainsbury, an independent researcher from New York State. And so I wrote to him and I got a copy of his issue, which was called Electron Structure. Now, according to the way particle physicists handle electrons, they're treated as a point electric charge, which is physically impossible because the energy involved in, a point is non-physical anyway. So it's a mathematical convenience. And that interested me because that offered, as Ralph Sainsbury showed in his small volume, it showed that you could explain magnetism and derive Ampere's law from the very simple idea of having an electron with a kind of atomic structure. In other words, it was made up itself of smaller charged particles orbiting at phenomenal speeds. One of the other aspects of that was that it also gave a handle on how gravity might work in terms of this tiny distortion of subatomic particles in an electric field. And he developed that, and I was very interested, but it took decades for me to come up with a slightly modified version of Ralph's work, which I felt answered most of the questions. And it started to form the idea of the electrical nature of gravity. And it answered the main questions. Why is gravity such a tremendously weak force? It's about 10 to the minus 39 of the electrical force between two charged particles. And that is as close to zero as you can get, practically.
Right.
And it's the reason why we're not reduced to something a micron thick on the surface of the Earth. If we were subjected to the raw electrical force. Instead of that, we can jump off the Earth. We can function quite happily in Earth's gravity. So the development of all of these ideas came initially from Velikovsky's work, and because it involved trying to reconstruct what the ancients were desperately trying to tell us with their stories, and the people like the Australian Aborigines with their oral traditions seem to have remembered details for thousands of years. They felt it was extremely important to hand this information down to subsequent generations. The problem for us is that none of the things they were talking about make any sense to us, simply because we've never experienced anything like it. Right. And hopefully we won't.
Now,
go ahead.
When we were removed from this environment around Saturn, how come we didn't end up like Mars?
Well, we could very well have, but Mars, interestingly enough, the ancients described exactly its situation. After Saturn gave birth to Venus in a brilliant outburst, like a nova type outpouring of material, it went into orbit initially about proto-Saturn, and because it was born from proto-Saturn, it was given a backward kick. That's why it has that odd rotation, retrograde rotation, because it was torn from its parent before it had time to set up a gravitational phase lock. Anyway, the ancients witnessed that, but when Saturn began to be accelerated towards the sun, it was pulled like a pip out of the centre of its little planetary system, and its satellites trailed behind. Closest to Saturn was Venus. It was the newborn one. Beyond that was Mars, and then there was Earth. Now, Mars was in the unfortunate situation in this plasma discharge from Saturn of acting as an oscillating charge carrier between Venus and Earth. So sometimes it was tiny and it seemed to be retreating into its mother's womb. And there's a lot of stories about that. And then at other times it approached the Earth closely, so closely that it must have been absolutely frightening. And then it was the giant. It was the giant that supported the heavens and fought with thunderbolts. It was the planetary god of war. And so it suffered terribly. And the evidence for that is written all over its surface now. It has kilometres of material ripped off its northern hemisphere, and it has a cratered southern hemisphere, and it's the kind of difference you would expect from the electrical model of discharging, acting as a cathode in one discharge in one hemisphere and an anode in the other, is exactly what will give you the effects we see. The giant gash across the face of Mars, which stretched for a third of the way around the planet, Valles Marineris, was observed by the ancients and recorded. Mars had a scar face. The American Indians called him Scarface.
A couple of things I wanted to get to before the end of the show here. One of the things was previous ice ages that the Earth went through. What was happening in those instances versus the most recent one?
Well, one of the questions is, how did we survive if we came in from outside the solar system and then were stripped off from proto-Saturn?
Yeah.
Maybe somewhere between Mars and Jupiter's orbit. Where we find the asteroids is likely where a lot of activity occurred, because the asteroids are debris from that kind of event. And so one of the things is that in the process of orbital capture, the electrical model shows that it's transfer of electrical energy which is involved in stabilizing the orbit. And that electrical energy would have had heating power. It would have heated the Earth to some degree. So although the radiation from the sun at times would have been very much less than we get right now, at some point in our orbit, it'd be like having a cometary orbit with terrible winters and terrible summers. And that is what the ancients complained about at various times, about the sun being too far away or too close, and the sky having to be lifted. There are a lot of stories like that.
But don't we have a cycle of ice ages, though, that go back hundreds of thousands of years?
No, what we tend to do is, because of the clockwork Newtonian model, there is this tendency to look for cycles which don't actually exist.
Okay.
The problem is that the very act of trying to date things geologically is based on radioactive dating. Now, radioactive dating assumes that radioactive decay is a constant process.
Right.
But if there's any interference from outside, particularly with the energies involved in cosmic thunderbolts, then the clocks are smashed, they're reset. All sorts of strange things will happen. And also it's been shown recently that radioactive decay is not a constant. It depends on the environment. And even the sun affects radioactive decay, our relationship to the sun. So we cannot use radioactive decay as an accurate dating system.
Just a quick question. Could you explain what a cosmic thunderbolt is?
Cosmic thunderbolt is an electrical discharge between celestial bodies, two planets, and it doesn't take the form of normal lightning, because lightning in the Earth's atmosphere is a thin filamentary type of discharge. In space, what happens is you get a thing, it forms a structure in a near vacuum. An electrical discharge will organize what matter is in that vacuum to form a structure called a plasmoid. And this is the kind of thing that was done, or the experimental work was done on decades ago, in the early decades of the 20th century. It's just unfortunate that plasma physics took a while to get off the ground compared to the standard physics, and therefore a lot of the ideas about what the sun is and so on was set in place by people who knew nothing about plasma physics, which is unfortunate.
Now, like the scar on the planet Mars, that would have been done from a cosmic thunderbolt.
Yes, absolutely. Yes. In fact, I've written on my website a description of what happened, because it took me a long while to figure out what it was precisely that was represented by that scar, because it has a distinctive shape. Mm-hmm. And that shape became clear to me when NASA published a picture showing the topography in different colors. And then I realized that shape is that of a barred spiral galaxy. And in plasma cosmology, a barred spiral galaxy is the grandest form of electrical discharge in the universe, in the visible universe.
Okay.
Interesting.
One of the things I wanted to ask you is a little bit off from what we've been talking about, but does the electric universe theory have any consequence on theories of consciousness?
Yes.
How so?
Because at the very heart of the particle physics of the electric universe is the fact that all matter in the universe is connected in real time, effectively, at least in the local universe. Obviously, it cannot be of infinite speed, but it's certainly far in excess of the speed of light. And the other thing is that so-called quantum events are merely the instantaneous resonant interactions between atoms, molecules, and particles. And this explains a lot of the so-called weirdness and strangeness of quantum theory. And of course, quantum theory is being called on to help explain consciousness. So it gives you the impression, and it's an impression, that we are a part of something much bigger than ourselves, and that consciousness is a part of it. And it's not just it's not in the brain. It's everywhere, if you like. We're a part of something grander than ourselves, because we represent a connection with the, if you like, intelligent universe.
Okay. Question from the chat room. Someone wants to know if you would say consciousness is then inherently electrical.
Oh yes, yeah, it is an electric universe, and I mean that not just at the the planetary interactions and so on, but at the subatomic level, everything is connected electrically. It's the electric force which explains all the others: magnetism, gravity, the strong nuclear force, and so on. It's all electrical.
Okay, and Cosmo Snake would also wanted to know if plasmoids came from space or also from the Earth.
They can do either. It depends on the polarity of the discharge, which way it goes. But the plasmoid it's like it was described by the ancients who witnessed these things or remembered them as like a coal spat out of a fire. In other words, it's an object. It has a physical appearance, and it moves from one planet to the other. So it's not like a lightning bolt at all. In fact, if you look at the carvings, the statues and that of Zeus hurling his thunderbolt, that thunderbolt that he's hurling looks like a football-shaped corkscrew.
Right.
That is one representation. Another one is the Tibetan dorje. It looks like a dumbbell with a very intricate pattern. That intricate pattern is part of the plasma discharge.
All right. You have anything you want?
Maybe if we could touch back upon an electrical model for a star. I've always been under the impression that we've observed thermonuclear reactions coming from the sun and can measure its radiation. How does the electric universe theory kind of mix in with that, or does it?
Yes, thermonuclear reactions occur at the sun, but not in the sun.
Okay.
The brightness that we see of the sun is all atmospheric, got nothing to do with anything going on inside the sun. The electrical energy that the sun receives is catalyzed in the solar atmosphere. In fact, we have seen, the evidence for the thermonuclear reactions is the neutrinos that we receive. But that's such a fuzzy image, you cannot tell where they're coming from. The sun is just at the center of this fuzzy image.
Right.
So there's never been any proof of the reactions that are supposed to take place in the center of the sun. It's all theoretical. And not only that, the theory is so damn complicated that you need a different theory for every different kind of star that you see. It is extremely complicated. The electrical model is very simple, and it explains red giants, white dwarfs, pulsars. They're not neutron stars. There's no such thing. And it's all one simple model.
Okay. Cosmo Snake also wanted to know, this is a great question, is there a main electrical source emitting from somewhere, or is the sun producing electricity itself?
That's a good point. One thing about electrical energy is that you can generate it in one place and send it for great distances and then use it somewhere else. And this is what the universe appears to be doing. We cannot say, this is part of the ongoing investigation, of course, where the power ultimately comes from. It's like one of those where did it all begin questions. We don't know the answers. We can begin to ask more sensible questions, however. What happens is that clouds of plasma, ionized material in the universe, when it's moving relative to other clouds of ionized material, will generate electric currents in each other. So that can be part of the answer, but it's not the full answer, because when we look at galaxies themselves, the galaxies are strung along intergalactic power lines. We can actually detect the power lines by their radio emissions and so on, and also the orientation of galaxies, which is not explained by Big Bang cosmology.
Now, it's almost like a string of Christmas lights.
That's right, yes. They're strung along power lines, just the same as the stars are in spiral galaxies. They're strung along the spiral arm power lines.
All right. And I would think that different suns and different, like the red dwarf or a brown dwarf versus a red giant is different to how much power they're getting?
Yes, it's the difference between the central object's electrical potential and the plasma environment it happens to find itself in. And a red giant is a star that expands its anode, if you like. This is how it works anyway. It expands its anode to collect enough electrons to satisfy the discharge. And in doing so, it appears an extraordinary size. But that size can vary quite rapidly and unexpectedly, and it's not explained by the standard model of red giants. They also tend to have very strong winds. Now, these are a cool star. Where do they get the strong wind from? Well, the strong wind, when you expand the anode glow, it accelerates particles, and those accelerated particles create that strong wind from red giants. And when you come to white dwarfs, a white dwarf is a star like the sun, but it doesn't have a bright photosphere. It doesn't require a photosphere to modulate its discharge, so it just has a corona. And that faint white glow that we see during a total eclipse is what a white dwarf is. It radiates strongly in X-rays rather than in visible light, and this is what we observe with white dwarfs.
And what about supernovas?
Supernovas are an electrical explosion. When you break a circuit on a high voltage power line, and you can see videos of these on YouTube, say a 500,000 volt, 500,000 volt intercontinental power line, you get this enormous release of energy and this great spark that arcs for meters up into the air. That's what happens to a star if it breaks the circuit. And you can do that in plasma physics with what's called a double layer. And a double layer can actually pinch the current off if it gets to a certain density. And it seems that a supernova is one where the electrical discharge causes an imbalance in the electrical stress inside the body so that it actually spews its insides out. And this is exactly what's been observed and has puzzled supernova experts, because they said it seems to turn itself inside out. And that's not explained by the explosion model.
When you're looking at all this stuff, when you're looking into deep space, are you seeing a direction from which all these electrical charges are traveling?
There's the radio astronomers that are important here, because the radio astronomers can track the magnetic fields generated by those electric currents. And one of the speakers at the conference this year, Ignacio Cisneros, is actually he's doing what they call the blink, where you superimpose two images and then just blink from one to the other. And he's finding changes in dust clouds. These electric currents tend to aggregate dust along their length, so you can sometimes pick them up as dusty filaments. And he's doing that and showing them changing rapidly over a short period of time, which is not expected gravitationally.
Oh, all right. We're just about out of time. Your site is hollowscience.com.
That's right.
The main Thunderbolts site is thunderbolts.info, and the EU 2015 Paths of Discovery is in Phoenix from the 25th to the 29th of June, with a list of speakers you went over at the beginning that is just amazing.
Yep. This is one of the good things too. We're attracting all sorts of scientists and engineers and lay people who some of them are actually doing experiments in their garage, would you believe?
But you do have a lot of accredited scientists behind this theory as well, including yourself, obviously.
Well, that's right. This is what we expected. We didn't expect an overnight acceptance of any of this. It's just a case of those scientists who are, the real scientists, the ones who are looking for the truth, will see which side better answers their problems, and eventually those with the courage will make the jump.
All right. Well, thank you so much for spending some time with us, Wallace.
Yeah.
It's been a pleasure. Thank you.
And good luck with the conference.
Thank you.
You have been listening to Where Did the Road Go? This show is made possible in part from our Patreons, and we thank you and everyone listening for helping us continue this exploration of the strange.